Hello everyone, myself Pushali Kateria. In this video we discuss propositional logic. Propositional logic is a part of the logic representation. Okay, logic representation is the first knowledge representation technique. Okay, we have a four knowledge representation technique: logical, semantic net, frame representation, and last one is the production rule. So here in previous video we discussed a technique or approach is in knowledge representation. Now we discuss in detail all representation technique. Okay, knowledge representation technique. So let's start with the propositional logic. Propositional logic is a part of the logical representation. Okay, logical representation have a four technique. First one is the propositional, second one is the FOL. It means first order logic, third one is the higher order logic, and fourth one is the fuzzy logic. Okay, so in this video we discuss first technique of logic representation. Okay, this is a propositional logic. So propositional logic is the simplest form of the logic where all of the statements are made by proposition. A proposition is a declarative statement which either true or false. It is a technique of the knowledge representation in logical and mathematical format. Okay, so first of all, propositional logic is the simplest and very easy method for a knowledge representation. Okay, in this propositional logic we use a proposition. It means we used a symbols or character, okay, for the particular sentence. In particular sentence, per sentence we have used a one character. Okay, so one character, it means we use any one alphabet from A to Z. Okay, propositional logic contain or propositional logic state declarative statement which either true or false. Okay, either it true either it false, not both. Okay, वो दोनों नहीं हो सकते, या तो फिर वो ट्रू हो गए या तो फिर false हो गए. True it means it is a binary declaration. Okay, binary declaration, it means either one or either zero. Okay, in this it is a technique for the knowledge representation in a logical and mathematical format. Okay, it used for the any statement, and propositional method is represent any statement any mathematical form. Okay, any kind of. Here I give one example for the statement and mathematical format for the propositional logic. Here it is a Sunday, so this is a propositional, so it is a true. The sun rise from the west. Okay, it is a false. Okay, because we all know that sunrise is not from the west. Okay, 3 plus 3 is equal to 7. Okay, this is a mathematical sentence say like 3 plus 3 is equal to 6. So this proposition is a false. Some students are intelligent, it means true, but some are not. Okay, this is a meaning of this sentence is some students are intelligent and another student are not intelligent, so it may be it's true or false both. So this sentence is a not give propositional. Okay, so here this sentence is not derived from the proposition. We will use for solve this kind of the sentence using a FOL. Okay, so here these three sentences are the propositional logic, and this one is solved by the FOL, first order logic. Propositional logic have a syntax and semantic. Syntax, it means let's let's discuss about the प्रोग्रामिंग लैंग्वेज. ओके, प्रोग्रामिंग लैंग्वेज में क्या होता है, अगर हम जावा बात कर ले, पीएचपी की बात कर लेते हैं, सी की बात कर लेते हैं, सी प्लस प्लस की बात कर लेते हैं, तो उसमें क्या आएगा, सिंटैक्स आएगा. सिंटैक्स इट मीन्स अगर आपको कुछ प्रिंट करना है तो सिस्टम डॉट आउट डॉट प्रिंट एल एन. ओके, प्रिंट एफ तो प्रिंट एफ ही लिखना होगा. अगर आपको कोई पीएचपी में आपको करना है तो इको डबल कॉट में ही करना होगा. अगर आप उसके सिंटैक्स में कोई चेंजेस करेंगे या तो फिर कोई मिस होगा तो वो क्या आएगा, सिंटैक्स एरर आएगा. ऐसे ही प्रोपोजिशनल लॉजिक में भी क्या आएगा, सिंटैक्स एरर आएगा. जो फंक्शन उसकी लाइब्रेरी में डिक्लेयर ही नहीं है और आप वो यूज करेंगे तो क्या आएगा, सिंटैक्स एरर आएगा. एंड व्हाट डू यू मीन बाय सिमेंटिक? सिमेंटिक इट मीन्स मीनिंग ऑफ द सेंटेंस. मीनिंग ऑफ सेंटेंस इज अ ट्रू or either false. So this is a syntax and semantic. This is a two way to represent the propositional logic. So when we derived propositional logic, then we focus on syntax and semantic of the particular sentence. Okay. Another thing is, these are the some basic fact about the propositional logic. So here let's we discuss. Okay, first one is the propositional logic is also called a boolean logic. It is a 0 or 1. It means 0, it means false, 1 it means true. In propositional logic, we use a symbolic variable, okay, any alphabetic variable to represent the logic, and we can use any symbol for the represent a proposition, such like A, B, C, D, okay, any A to Z from the A to Z alphabet. Propositional logic have a two type. First one is the atomic and second one is the complex. Atomic, it means our sentence value is 1. We have only one sentence, then we use atomic. Okay, atomic, like sky is a blue, it is a Sunday, today is a holiday. Okay, this kind of the sentence is like a, is we can say like atomic sentence. Okay, and another thing is a complex. Complex, it means we have a more than one sentence. It means uh, today is a Sunday, so today this day is a, we can say like this day is a holiday. Okay, like that. So if we have a multiple sentence, then it is a complex. Okay, and if we have a one sentence, then it is a atomic. Okay, proposition can be either true or false, but it cannot be both. Okay, we have already discussed about it. Propositional logic consists an object, relation and function and logical convenience. These logical connectives. These connectives are also called a logic operator, logical operator. We will discuss in our further slide. Okay, or further in next video we will discuss a logical operator as one topic for the proposition logic. In this video we discuss only syntax for the propositional logic, also operator for the proposition logic. So first of all, here rule for conjunction, it not, this one is a not conjunction, this rule for the negative operator. Okay, not operator, not operator. So first operator is a negative operator. What do you mean by negative operator? Negative, it means not operator, not. Okay, keyword as a not. We also use like a not, not P, not A, not B, like that. A sentence such as a not P, this is a symbol for the negative operator. Not P is called a negation for the P. A literal can be either positive literal or either negative literal. Okay, first so here example like today is a Sunday. Okay, so what is a negative sentence for this? Today is not Sunday. Okay, P is today is Sunday, then P is a today is Sunday, then not P is today is not Sunday. Okay, another is a today is a not Sunday, then negation of this kind of the sentence, today is a Sunday. So वन का क्या होगा, ट्रू का फॉल्स हो जाएगा और फॉल्स का ट्रू हो जाएगा. वन रिप्रेजेंट अ ट्रू वैल्यू एंड जीरो रिप्रेजेंट अ false value. Okay, this value we I have a refer in whole video or a whole chapter. Okay, so here I have a represent like this. One is a represent true value and zero is a represent as a false value. So this one is the rule for the negative operator. So this is a not operator. Okay, not operator, this is a sign for the not operator. Second one is the रूल फॉर द एंड ऑपरेटर. ओके, एंड ऑपरेटर के लिए रूल क्या है? तो एंड ऑपरेटर के रूल ये है कि अ सेंटेंस विच हैज अ एंड ऑपरेटर कनेक्टिव such as a P and Q is called a conjunction. Okay, so here this is our example, like Rohan is intelligent and hardworking. Okay, so this one is our sentence. P as a we have a represent as a P. Rohan is intelligent, and Q is equal to Rohan is a hardworking. So now we derived truth table from the P and Q. So here P and Q. Okay, so what is the possibility for the P and Q? So first of all we can write like this: true, true, 0, 0. If we have a two proposition, okay, This one is a P proposition and this one is a Q proposition. If we have a two proposition, then we have a four possibility for all. Okay, so what is a possibility? How can we find a possibility for the proposition? Then we can write like this: P have a true value, false value. Okay, Q have a true false value. Okay, so we have a four pair for the two proposition. One is it can be both true, it can be both false. Okay, P is a true, Q is a false, P is a false, Q is a true. Okay, so these all possibility are right like this. So here it is our convenience part. So first of all we can write like this: P and Q proposition. Okay, and then we can write like this: 1 1 0 0 1 0 1 0. So true 0 0, true 0, sorry, true false. Okay, so now we find P and Q proposition for the P and Q. Conjunction part we can here we will find for the conjunction part P and Q. So what is our example? Our example is a Rohan is a intelligent and Rohan is a hardworking. Okay, if Rohan is a intelligent, then and Rohan is a hardworking, this is a true, because if अगर रोहन है वो इंटेलिजेंट है तो वो क्या होगा, तो वो हार्ड वर्किंग भी होगा. ओके, हार्ड वर्कर भी होगा, इसीलिए ये वाला क्या है, ट्रू है. ये सेंटेंस क्या बोलता है, पी वाला ट्रू है, क्यू क्या है, false है. It means Rohan is intelligent but it is not hard working. Okay, Rohan is intelligent and Rohan is not hard working. It is not possible because वो intelligent है तो वो hard worker ही होगा, इसलिए वो क्या है, false है. ठीक है, इसलिए zero. If Rohan is not intelligent, okay, Rohan is not intelligent, then and Rohan is a hard working, this is not possible, so this also false. Okay, and Rohan is not intelligent and Rohan is not hardworking. Okay, so this is a simple, both are false, then output of our sentence or our conjunction are also false. So it can be easy for the write like this: 1 1 0 0 1 0 1 0. Okay, if both are true, then our conjunction and operator are 1, it means true, another are 0. ओके, ये आपको क्या करना है, याद करना है, क्योंकि हमारा जो प्रोपोजिशनल लॉजिक है उसको आपको कुछ सेंटेंस, कुछ सिंटैक्स आपको दी जाएगी कि आपको ये वाला फंक्शन है, आपको ये वाली सिंटैक्स है वो सॉल्व करनी है. तो आपको क्या करना है, मल्टीपल एंड ऑपरेटर, नॉट ऑपरेटर, इम्प्लाइज ऑपरेटर और ऑपरेटर, ये सारे ऑपरेटर को यूज़ करके आपको एक सेंटेंस देना है. उसके हिसाब से आपको ये ट्रूथ टेबल बनाना होगा. उसमें आपको मल्टीपल वैल्यू भी, मल्टीपल प्रपोजिशन भी आएंगे. तो आपको क्या करना है, ये वाली वैल्यू याद करनी है. इट मीन्स अगर दोनों ट्रू है तो ही एंड में ट्रू आएगा, अदरवाइज एंड में ट्रू नहीं आएगा, एंड में और सब फॉल्स आएंगे. ओके, अनदर रूल फॉर द डिस्जंक्शन फॉर द और ऑपरेटर, इट मीन्स इट मे बी और नॉट. ओके, Rikita is a doctor or Rikita is an engineer. Okay, either she is a doctor, either she is a engineer. She is not both. Okay, वो दोनों नहीं हो सकती, का तो वो डॉक्टर हो सकती है, का तो वो engineer हो सकती है. Okay, और operator represent like this kind of the symbol. Okay, this is a disjunction symbol or disjunction connective operator. Okay, such as a P or Q is called a disjunction where P and Q are the proposition. Here one example: Rikita is a doctor or engineer. Okay, so we can write like this: P is equal to Rikita is a doctor and Q is a Rikita is a engineer. Okay, so first of all we can write we generate our truth table for the true false. Okay, so P proposition contain a true two true value and two false value, and Q contain a also two true value and two false value, but in disorder. Okay, so here let's start. P or Q. Okay, Rikita is a doctor or Rikita is engineer. Then Rikita, it can be either or doctor, either engineer. इसमें क्या है, या डॉक्टर है या तो फिर इंजीनियर है, उसमें से कोई एक पॉसिबिलिटी होगी, तो ये क्या होगा, ट्रू. Rikita is a doctor, Rikita not engineer. It means Rikita is a doctor. Okay, so it means true. Rikita is a not doctor, Rikita is an engineer. Again is true. Okay, Rikita is not doctor and Rikita is not engineer. It means false. वो दोनों में से एक तो है ही है, हमें पता नहीं है क्या है, बट वो क्या तो डॉक्टर होगी या तो फिर engineer होगी. Okay, so this is a false. So again you can mug up this thing for, okay, for your reference, like if in or operator, if both are true, then it's true. If any one sentence are true, then it's true. Okay, if both are false, then our output is a false. Okay, another rule for the conditional operator. What is a conditional operator? Conditional operator contain if and then rule. Okay, implications are also known as if and then rule. This is a sign for the condition operator. Okay, arrow type. This is a arrow type for the P condition Q. P then Q. Okay, if P is a true, then Q is a if P, then Q is a action. Okay, this is a condition, this is our action. So our example is, if it is a raining, then the street is a wet. Okay, so first of all we derived or divide the two sentence in a two proposition. First one is a P is equal to it is a raining, Q is equal to street is a wet. Okay, so uh, we generate a truth table for the P and Q proposition. Okay, same condition. Now what is a P implies Q? What is the value for the P implies Q? So first of all, if it is a raining, then road is a wet. So this is or street is a wet. So this is a true. Okay, if it is a raining, then street is not wet. Okay, अगर रेन हो रहा है, अगर बारिश हो रही है, तो जो स्ट्रीट है, जो रोड है, वो गीला नहीं है. ओके, तो ये वाला ट्रू नहीं है. क्यों? क्योंकि बारिश होगी तो रोड गीला होगा ही होगा. ठीक है, तो ये वाला क्या है? फॉल्स. इफ इट इज अ रेनिंग, इफ इट इज अ नॉट रेनिंग, देन स्ट्रीट इज अ विट. इट मे बी पॉसिबल बिकॉज रेन नहीं हो रही है, बट कोई साफ सफाई चल रही है, कोई काम हो रहा है, तो मे बी क्यू इज अ पॉसिबल. ओके, सो दिस इज अ ट्रू. And if it is not raining, then street is not wet. So it is also true because rain नहीं हो रहा है, बारिश नहीं हो रही है, तो रोड भी गीला नहीं होगा. So it is a true. So it is a truth table for the conditional operator. Another is a biconditional operator. Biconditional operator is a double implies if and only if. Okay, if and only if our sentence are contain if and only if this kind of the keyword, then this is a biconditional operator. Okay, so what is a biconditional operator? Biconditional operator, if I am breathing, then I am alive. Okay, so here we derived our sentence or proposition. P is equal to I am breathing, and second one is a Q is a I am arrived. Okay, sorry, arrived nahi, alive. Okay, so it is, this one is our truth table. Truth table for the P and Q. P double implies Q. Okay, double, we can say like the double implies. This is our single implies and this is our double implies. Okay, this one is our single implies, this one is our double implies. So if by conditional sentence, if I am breathing, okay, in our truth table, if I am breathing, then I am alive. Okay, so this is a true. If I am breathing, I am not alive. This is a false because अगर मैं सांसें ले रही हूँ तो क्या होगा? मैं जिंदा हूँ. Okay, so this sentence is a false. Okay, if I am not breathing, then I am alive. This is a false value because अगर मैं सांसें नहीं ले रहा हूँ तो मैं जिंदा हूँ नहीं हूँ. ठीक है, तो this is a false. If I am not breathing, then I am not alive. So this is a true because अगर मैं सांसें नहीं ले रहा हूँ तो मैं alive भी नहीं हूँ. So this is a false, sorry, true value. Okay, so it is a biconditional sentence, or this is a truth table for the biconditional sentence. Okay, and now this is a last slide for the propositional logic connectives. Okay, this is a connective symbol for the and. Okay, and like that word, connective symbol, connective word is and. Technical term is a conjunction. Okay, an example is a and b. This is a symbol for the or. Okay, word is or. This technical term name is a disjunction, and this is an example for the a or b. This is a single implies, we can say like the single implies or implies only. Okay, this is the implication or conditional operator, or this is an example for the a implies b, if a and then b. Okay, this is a double implies, it means if and only if. We can say technical term in a by conditional. This is a example for the if and if a happen, then b always happen. Okay, or b agar b happen, then a is always happen. Okay, so this is a implies b is equal to b implies a, both are same. Okay, this is a not operator. Okay, this is a not and not, both are sign for the not. Okay, and this is term for the negation, and these are the example for the negation sign. Okay, so this is a summarized table for the propositional connective. In this video we have discussed about the propositional logic and very basic rule for the proposition logic. In next video we will discuss example for the proposition logic, how we will solve example for the particular proposition for the complex sentence. Okay, so thank you.